Give an example of a polynomial in standard form with roots 5 and 2i. Well, as soon as the imaginary number 2i is given as a root, then we automatically know that negative 2i also has to be a root. Imaginary roots always come in pairs. So this problem is actually asking us to work backwards. So if you have, it's telling you that x is equal to 5, that's one of the roots. That x is equal to 2i, that's one of the roots. And x is equal to negative 2i. Now I say working backwards because quite often we're given a polynomial or an equation, set it equal to 0, either use factoring, quadratic formula, whatever you've got, to then solve for x. So usually this is the answer, not the question. So now I need to work backwards. So if x equals 5 was the answer, and that's the final step, then the step right before that must have been x minus 5 equals 0. Likewise, x minus 2i equals 0. And here, x plus 2i equals 0. Then the step before that is that it must have been factored, and these were the factors. And then all we need to do is multiply this out, and then we'll have the polynomial. So it's best to multiply these two together because they are conjugates, which means that you only need the first term times the first term, so x times x is x squared. The middle terms are going to cancel. This negative 2i times x will cancel this positive 2i times x. So now we just need the last one times the last one, which is going to be negative 4i times I, or I squared. Well, I squared is equal to negative 1, so a negative 1 is going to change this into x squared plus 4. And then just multiply out what we've got, the two terms times the two terms. So there's x times this is going to be x cubed. I'm going to keep the terms in order, so next I'm going to distribute this to the x squared, so minus 5x squared. Then the x term will come from the first one times the last one, so plus 4x. And then for the constant, negative 5 times 4 is negative 20. And then we could call that a polynomial, f of x or y equals or something like that. But that would be it.